Okay, hello everybody. Thank you for joining us at this session in this quite a big number. I hope this will be boring session, boring topic, but it looks like not. Anyway, today we'll talk about AWS Fargate service. When the manager suggests this topic, I said, well, this is last year's news. It's nothing new. There are some new kids on the block who are more exciting to talk about. But then I realized that we have like, I don't know, 5, 6, maybe even more services in production who are running this particular service. We even forgot that we deployed a service on this using this technology, and they are just working like it's supposed to be. So I may say this technology is maybe a little bit older than some new which are available, like a Kubernetes or stuff like that. But it is mature. It is very stable and easy to use for even just beginners. But first, let me introduce myself. So, as the colleague said, my name is Alen. I'm project manager at Ingemark. I'm also a member of our DevOps team. I'm also Linux system administrator for a number of years now, certified AWS SysOp administrator, and a number of these things. I'm coming from the company named Ingemark. We are a Croatian company, not big, 35 employees, almost 30 years in the market. We have a lot of customers in the region. I don't want to give them a name, especially a lot of in the region, a lot of in the United States, some of them even in the Middle East. And we are heavily relying on the public cloud. We became a partner for a quite number of years with the AWS. Now we are also partnered with the VMware for the cloud technologies for on-prem data centers. We like to declare ourselves like a software development agency. And basically that's what we are doing. We are developing code. But in the recent years, a lot of our customers actually invited us to integrate and deploy our code to their environment. And that's why we start doing these integration tasks, cloud consulting, moving, basically DevOps functionalities generally. And that was quite a journey, I can assure you. A lot of different environment, a lot of different things to be implemented, integrated, even with our code, but we know how it's supposed to work and what are the dependency for them. And we decided to adopt some new technology just to overcome issues between deployment and stuff. And one of the best technology available today for us, which we are heavily rely on, is really containers. And containers are really something which is changing infrastructure and IT industry I can say on very fast track. Just to pause a second, do you know what are the containers? Is anyone using containers in their application? Okay. Okay. I thought I missed the room. Okay, for all those who are just exploring and for all those out there who are just testing the technology or looking for the basic features of the technology, I may say that we like to describe the containers like, let's say, a snapshot of the operation system who is excluded everything what's not needed for the application, the service itself. So it's very small and very easy to run. And containers is heavily relying on the operation system layers, who is bringing these major features, which is actually application rely on. So containers are very much optimized our everyday activity, because once we decided that features should be published or released, we put it in the container and deploy or deliver to our customers who can easily put it without changing. Once we sign this container, it can be easily used in even production systems. So containers are great, and containers are also enablers for some other technology. One of these technology is microservice architecture. I believe that you all heard about that, because they are quite convenient way how to package and how to interconnect these using networking feature of the Docker engine and stuff like that, how to interconnect these little services and how to connect with each other using maybe API, maybe some messaging application or service or systems, whatever. But these services also, and this technology is also opening some new challenges, new constraints. If you want to put microservice architecture who can have, let's say, 20, 30, maybe even 100 containers in high availability, fault-tolerant environment, then you have to come up with an idea how to handle that, how to handle deployment, how to handle monitoring, health checking, and stuff like that. Luckily, we have orchestration tools, which are already available in the market. But one of the oldest orchestration tool available at the AWS is ECS service. It's like a managed service, acronym for Elastic Container Service. And it's alive, I believe, since of the 2015, July, if I'm not wrong. And at the beginning, they rely on the EC2 instances to put the container which you already built and shipped to the cloud to run these containers instead of you in the cloud. And this was very simple. Just use simple commands, create a cluster, decide what EC2 instances you will use for your workloads, ship your containers there, and ECS will take over everything. It will monitor, it can be easily integrated in the CI/CD pipeline. You can use everything fully automated from the AWS, or you can build your own, let's say, Jenkins pipeline and integrate with this service. But what and the second service released, I believe, last year, is Elastic Kubernetes Service, and this is new kid on the block. I believe that everybody heard about Kubernetes. And in my next session for the VMware, I will talk about Kubernetes a little bit more. But ECS is really mature, really easy to install, configure, and everything like that. But the basic change from the beginning to present is that instead of configuring, managing these EC2 instances, which we use to host our containers, now ECS go serverless using Fargate technology. So modern installation simply use AWS infrastructure to host your containers without actually any need to organize or instantiate any EC2 instance. Just take care of your containers and put it somewhere, and AWS will take care where to put it and how to. If we compare old service to the new one, on the left-hand side, your left, there is let's say a schematic presentation of the service. You have control plane who will manage all the features of the service. Then you have EC2 instances which are already, if you are using ECS AMIs who are prepared for this service, they are already prepared and uploaded with the ECS agent who will communicate with the management plane and who will notify management plane about things which are going on the cluster nodes. And then you have these Docker agents, and then you have other things to do in maintaining these things. You have to patch it, you have to secure it, you have to take all of these heavy lifting just to host your containers. And that's the change which is Fargate bringing to the service. No more EC2 instances, as you can see. Nothing there. You have only containers to take care about. So you still have the control management plane from the service. Service has to be there, has to be organized, has to be isolated from maybe other services, but then you just have containers with their code and with their description. How many memory, how many CPU, and some other features which we'll see on the next slide. Thanks. So, for those users who were already start using and maybe digging a little bit deeper into ECS with EC2, these are main building blocks. These are task definition, who will actually force you to describe your container. Where is your registry? Where is your image located for the container? Which version you are going to use? What memory and the CPU configuration will be used? Then which networking driver you're going to use for the logging as well. One small disclaimer, in this release with the Fargate only two logging drivers are supported, ECS CloudWatch, my brain stopped, and Splunk driver. And all other drivers are still not supported, and they promise they are going to be supported very soon. Then you have a service who will actually integrate your tasks and your containers with some higher level of abstraction, integrate with load balancer, bring up the auto-scaling with both these fancy features. They offer the target tracking and step scaling, I believe, still. Then you will have to describe how many copies of these containers you want to run always. And of course, you will have the opportunity to change this automatically via CLI, via co-deploy, via whatever. I mean, you can use every feature available out there to change these parameters during the runtime. And of course, you have the cluster definition, who is basically isolation of other cluster and integration with the EMI. For these users who already use the ECS with the EC2 combination, basically for the smaller installation, one line can be changed, and this configuration can be used with the Fargate as well. Just change the driver. And this is the biggest change which has to be implemented with the Fargate solution. If you remember how Docker engine works for all those locally handled containers, he is relying actually on the network interface attached to the EC2 instance. When you want to go serverless and don't own the EC2 running instance, then you cannot choose how you will operate on that ENI, on that network instance. On the EC2, you had the opportunity to choose between bridge or host networking while running containers. But on the serverless, this is something a little bit different, because you cannot change behavior of underlying host, because you don't even know where it will be going, where it will be hosted, your running container. That's why Fargate brought one fancy solution, who is actually bringing up the network interface to the container itself. Therefore, we are now have opportunity to look at our running containers, operating containers like almost like a virtual machine. And there are some hacks who allow you to connect to your container directly on the available IP address. Because they are looking like a virtual machine, you can put these containers in the public subnet and allow users access directly from the internet if you want to do that for some reason. Or you can put it in the private tasks setup, in the private subnet, where you will expose it via some other service, load balancer or something like that, or some maybe firewall, or some router or some other service which you want to use to secure your data. So this is one of the biggest change which is Fargate bringing to the ecosystem, to the running service in production. One other thing which is also changed from the last version, from the EC2 version, with the EC2, is permission. If you want to run your container in the ECS cluster, you had to dedicate some special permission to the instance itself via using IAM roles. If you run multiple containers on the same instance, because this is just normal, then you will put all permission which your containers are needing into the same role. And this is something which is not very much secure, because all running containers can assume that they have all these permission which actually any of these containers is actually needed. With the Fargate, the team brought up one new segment called ECS task role, who is actually forcing you to define permission just for that container. So it's much more clear, it's much more secure, and it's much more easier to maintain, because now you have to handle separately roles for every running container or for every running service. I mean, you can share these roles among other containers as well. As this is serverless platform, it's very well integrated with the CI/CD pipeline, which Darko showed us in the earlier presentation. Because of the great support with the SDK and the cloud formation, it can be fully automated. I mean, just a single click can bring up whole environment with all these needed prerequisites and can be easily implemented in every CI/CD pipeline. So what we are using, I mean, we are not using code deploy and code pipeline because we are relying on our services. We are using Jenkins for some project. We have these pipelines who are organized in a way that every build is at the end. Every build who is executed after the code commit is actually production release ready container. So all pipeline from the beginning through the revision, through the testing to the security scanning is automatically deployed to the ECS for on demo or staging environment. And it's manually deployed if all tests are fulfilled and qualified, then everything is manually deployed to the production. It can be, I told you, automatically configured, automatically destroyed when needed, and simply using CloudFormation. What are the major benefits of this technology? You can now take care of the application. You don't even need to measure your performance and perform all these performance testing before you deploy and organize your code. You don't have to think about EC2 instance in the fleet you have to utilize. It's simply load up the containers, start the performance testing, and then you will decide which combination is best for your workload and your use case. No infrastructure. No more heavy lifting just to handle and host our containers. If you want to run containers on the ECS, I don't care about the EC2 instances, about the patching, about CIS compliance, about PCI DSS, because everything what is important for this compliance is handled by the AWS. I have to take care only of the application code and the container security itself. It's very easy to launch. You can configure the service using console very easily, or as I said, CloudFormation, because it's only 20 lines, I believe, just to configure and deploy this. As I said, it can be easily configured to use the autoscaling. And autoscaling, as these containers are really small, they are only 100 megabytes, I believe, and even smaller, complete with application. Scaling is a matter of seconds. Literally. If you have to scale something and if you configure this scaling, it will add these new containers very, very quickly and in a very fast manner. Resources. ECS is basically free. No charge there. ECR for the container registry, which is directly integrated with the service, is also free. You only have to pay for the storage. And here you only need to pay for the containers, which for the CPU and the memory for the containers. How many containers have? There is a pricing list for every combination. It's charged by second, and it's charged by CPU usage and memory usage. So this pricing tag is also forcing us to take care about the definition of the container. Most of the users who are using container never bother about this. I will load this on my server. This server has enough resources, and I don't have even to think about limitation of the operating container, which is really false. Nowadays, with the pricing, the AWS is forcing you to think about these resources just even before you launch them. Which are the best use cases for this? I may say large and small workloads, because you can change or you can choose your combination of the sizing. You can use small CPU with the 1 meg of memory, or you can use 2 CPUs or 4 CPUs with 8 gig of memory. I mean, a lot of these combination, and you will pay for the usage of these combination. So Fargate brought up one good feature which is called scheduling. You can schedule your container to perform just a specific load in a specific time and close. So this is perfect usage for this kind of batch workload. If you have to do something occasionally, once in a day, once in a week, or even once in a month, you just have to schedule this container, deploy it, and put it to work. The internal scheduling system will take care of this service. That's basically it. Do you have any question? Anything? Just a second. I do have, at the beginning of the year, we kick one of the service using this technology. It's for music streaming. It's a Deezer-like or Spotify-like a service. So it's completely operated serverless and using Fargate technology. And if you're willing to give a try, this is 30 days free voucher. So you can use it and try it and check if serverless is performing very well. This is scaled for 100,000 of users. Okay, any question? Thank you.